Welcome back, everybody, to our final presentation of TWSS 2021. It has been a very good event. Just looking at the participation we've had from so many different countries around the world, I want to thank everyone for spending so much time with us. I want to let everyone know just at the beginning, a few notes. If you have questions, this is a dual presentation. So if you have questions during the talk, you can ask them in the Q&A, and we will either, John will probably answer them when he finishes, and then we can move on and answer David's at the end, or we'll answer both. We'll see how our speakers feel. But please type the questions in as you have them. All of our talks are being recorded and will be available on YouTube by the end of next week. So we already have our opening presentation is already up and ready to watch. So please take advantage of that, and we will send out an email to everyone when all of the videos are finalized and done. We have two speakers for this final talk. The first is Dr. John Cary, CEO. You know, as far as a bio, well, he kind of started this all. He's been at TechX now for 26 years, I believe. He's also a professor at the University of Colorado. He's been there even longer. Dr. David Alexander, his background is that he received a physics PhD from the University of Colorado at Boulder in experimental plasma physics. He's been working at TechX since 1997. Over the 24 years, he's done research and development in visual interfaces to scientific simulations, distributed technologies such as cloud computing and physics analysis workflows on high performance computers. In addition, he's our Director of Quality Assurance and Releases, and he oversees that VSim and all of our other products work well for our customers. All right, John, take it away.
Thank you for that wonderful introduction, Colleen. Yeah, 27 years in this company, and at the University of Colorado, I've been there since 1984. So that's 37 years, I think. And so, however, I do want you to know that I started both of those endeavors at a very young age. So anyway, but let me move on today. I'm really thankful, and this is my opportunity to thank everybody who works so hard here at TechX to bring you the best possible modeling tools. And so I won't have a chance to finish up. David's going to finish up. Maybe I can say something at the very end. But it really is gratifying to see the people working so hard, being so productive, and producing such great things. So we've been playing around with how would we move VSim onto the cloud. And so I'm going to go through here and let's see, talk about what you might do. Now, we have three different ways of thinking about the cloud. We have what we call the private cloud, and that's where you set up something in your institution so that everybody can work on VSim through a browser without installing anything. We have what we call the public cloud, and Dave will be talking about that, and that's where you do something on publicly available hardware, such as Amazon. And then we have something called the public-private cloud. And the public-private cloud, I just coined that, is a cloud where we will provide the machine and you can come in and do some simulations on it. And we haven't quite figured out the licensing or how to charge yet. So if you'd like to give it a try, do let us know. And for the next month or so, we'll be glad to let you play with it. Tell us what you like, what you don't like, and whether it's worth continuing with that effort. But today I'll concentrate on the private cloud. And the private cloud, as I said, is a way to share a cluster at your institution or a workstation. And you want to share it throughout your institution. And why would you do that? Because your institution might have a single compute machine that's very powerful, like a very large core workstation and with a huge amount of memory, and they don't want to put one of those, it might be a $50,000 machine on everybody's desktop, or it might have a cluster. When you buy a VSim for a single machine, and a single machine can be either a single workstation or a cluster. And a cluster, we have a definition for that. It has to be a queuing system, common file system, et cetera, et cetera. you get a very cheap price for every core you enable as you buy more cores. So for example, it's $833 a core for the first core on a single large machine, like a cluster, but it's only $40 a core once you get about 512. So you buy one large cluster and it's a whole lot cheaper than buying a whole bunch of, buy one cluster license is a whole lot cheaper than buying a bunch of licenses for a whole bunch of workstations on top of the desks of many people scattered throughout your institution. And the nice thing about this is that you, the user, get to avoid any download, any installation, any additional licenses. It's all put on your system administration people, of course, your IT people, but they have to do it only once on that one cluster or that workstation. So it cuts down on IT costs, it cuts down on hardware costs, and yet you get the same capability. Now, I'm going to talk about how to do this I'm going to show you how to do it on a 24-core workstation, but in fact, it works on a cluster. And so that is one of the other advantages. And finally, you might want not to take advantage of a public cloud because you might want to keep your data on-prem. For example, if you're Raytheon and you're doing some classified research, you can't go put your stuff on Amazon. And my experience is that sometimes even more rigorous security I find at places like Intel, where they are very afraid of anybody seeing their data. And the only way they have confidence in that is keep it on their machines, in their rooms, behind their locks and their firewalls. So if those are the things that apply to you, then this is going to be a good solution. So now let me tell you about some requirements and give you some terminology. So a compute node, we're going to talk about that. The compute nodes are the backend nodes or the cluster nodes. And what they need is to have a licensed VSim installed on a shared file system accessible to all nodes. If it's a workstation, they just need to have VSim installed. Nice to have as a queuing system. Well, you'd have to have that for a cluster, but you can also put a queuing system on a workstation. And what that does is you can limit the number of people computing at any one time so they don't step all over each other. We happen to use the queuing system called Slurm. Other queuing systems, this will work with other queuing systems as well. Some of them, we haven't quite got everything working, but we're happy to work with you to make sure that it does work. Now, then there's something called the head node for the workstation. That's just the workstation. But if it's a cluster, then you have a head node where you can launch jobs on your cluster. You need to have VSim installed there too, and on a shared file system so that it can be found by the compute nodes. And next you need to have this thing called No Machine installed. And No Machine is a piece of software that you can purchase and install on your computer and allows you to execute things through a browser. As I said, it's nice to have a queuing system to make sure people don't step on each other. You'll need a web server on your head node or on your workstation, and to transfer files back and forth, you'll need an SSH server. And finally, what you need on your client, and in my case, that's my desktop machine, is I just need a browser. So we've set all that up. We have an excellent IT team here at TechX. So I'll just go over to my browser. And of course, like everyone, I'm sure, the first thing you see on a browser is the TechX homepage. I hope that's your homepage. If it's not, I could show you how to configure it so that it is. And of course, over here, to show you it's a browser, is our TWSS schedule. And we're in this very last talk. So we're just about done here. But in the third window here, I'm about to go to a particular URL. Let's see what happens. And when I go to that particular URL, I've already logged in once and disconnected, and now I've logged in again. So I didn't have to put in my password. Oops, didn't want to do that. Let's see. How do I get rid of that? Sorry. I don't know what happened here. Goodness, this has never happened to me before, that this piece of software is interfering with what I want to show you. Well, why don't we switch to Dave right now while we figure this out? So I'm going to stop sharing, Dave, and you can start sharing, okay? And we can go to you.
Okay, I can do that. Yeah, so we'll talk a little bit about the public cloud. And that is, I'm going to show you a new exciting web app that we've developed here at TechX to access Amazon Web Services. And a little bit more about why you'd want to do this. And John has talked about some of the reasons why you might want to move to the cloud. But in terms of public cloud, you might want to have resources that your institution or organization just can't buy. I mean, if you might think about having a 32-core workstation on your desktop, which would be really nice if you can have the access to a workstation that is beyond your means of your institution or your organization. So I'm going to show you how to really get a large number of resources available at your fingertips. Another reason why you might want to use a public cloud like AWS is you're not really sure of the computing requirements that you need ahead of time, and you want to remain flexible. And you might also have a iterative design cycle that computing is a smaller portion of, and so you may not want these powerful resources available all the time to you, and you might want them just as a part of your design cycle. As John talked about, the hardware expenses, the IT support team, the maintenance of that hardware is a cost consideration. And on the public cloud, you avoid all of those. And finally, you may want not to have any software downloads or any software installations or licensing operations to put on anybody in your team. So that's another reason why you might be interested in the cloud. And so let me kind of describe in a little bit more detail about the cost comparison. At the top of this slide, I have kind of some rough estimates of what a do-it-yourself machine. I looked up the cost for a 32-core Dell workstation with 256 gigabytes of RAM. And then these rest of these costs are very fungible, but I think I've got them to the right order of magnitude. And it's just nice to see the list of the costs because you don't always think about these kinds of costs. There's the IT team has to create user accounts on the machine, has to network that machine, has to install software on that machine. You have to pay for power for that machine, the cooling of the room that it's in, the internet connection service provider. You have all sorts of extra auxiliary equipment for power redundancy and then repair and replacement costs. So, so roughly that's a picture of the first total month's cost of a machine. It's a nice medium power workstation sitting on your desk. And if you were asked the question, well, what if you wanted to go into Amazon and get that kind of similar machine? And here again, I didn't do any benchmarking testing of exactly the same machine, but I picked out one that I think is close. The virtual CPUs are 64, but their typical default representation is hypercores, I believe. So there's 2 threads on each core. And so I picked a 64 instead of 32 to give a fair comparison. But you can see $3.20 an hour. If you take that $3.20 and divide it into the 21,000 into that, you get 6,819 hours, which is almost a year of solid compute time for your first months of cost. So that's a good kind of rough estimate of how it could be a cost savings for you if you're only doing a short-term project. And another thing to consider when you're considering costs and whether or not you want ownership or you want to fire up cloud computing resources is, you know, how it fits into your whole process. And here's just a kind of an average description of a common iteration cycle where you have a vision and you continue on with a certain number of iterations. And maybe you're considering doing computing, simulation computing in the yellow and the red parts of the design cycle. And you don't know how many iterations you want to be doing when you first start. You don't know how much simulation time you're going to need. So why pay for a whole machine being there the whole time? What we developed, what we're working on now is we call it VSim, and I'm going to show you it. But it's basically at an abstract level, it's a partnership between TechX and Amazon where you pay as you go. And I'm going to show you how you're actually using your own Amazon account. So you're going to be paying Amazon for the hardware resources, and then you're going to be paying us for access to VSim. And so that's why I'm calling it a partnership. And it's really about choices. And so what we hope to do with CloudSim is provide you with some helpful documentation on how to set up your Amazon account and connect it to the CloudSim service or web app, and get on-demand access to high-performance hardware where VSim is pre-installed. And I will show you also how it integrates into various kinds of workflows that you might think of doing. And I will show you some, and it's very flexible, and you will see how it will possibly fit into your particular workflow. So I'm going to show you this service or web app. And so let's take a demo. Let's take a look at it. Here's a web browser. I don't have TechXX on my homepage, so maybe I'm going to get fired here by John. But I'm going right to the CloudSim app because that's what I wanted to show you. So it basically, there's 4 parts. You need to create your CloudSim account with us. You would need to create an Amazon account with Amazon, and then you would start up resources that already have VSim installed, and then the 4th thing would be simulating VSim. So let me sign in my demo account, and this is the dashboard page. It shows you the instances that you have started. So these are 6 machines that I have running. Well, they're not all running, only 2 of them are running and 4 of them are stopped, but they're all, they've all been created on my Amazon account that I've set up for CloudSim. And I'm going to show you one of them, but first, let me also direct your attention down to the bottom where you can start a new instance. And I have, just as a kind of a proof of principle, built in 3 kinds of instances: a free instance, a medium fast instance, and a fast hardware. The free is, of course, free. The medium is about a 10 cents per hour kind of machine, and the fast is about a $3 machine. But let me go ahead and just log on to one of the machines that I already have running. And so here we provide a connect button, and when I click this connect button, I will get another browser window with the no machine. And I will try not to click the same thing John did to get whatever he did, I'm not going to do. So here's VSim running on an Amazon instance. So this is, you can see here, it's Amazon.com. So it's a machine that's running in the Amazon cloud in my account. And I'll show you later how to set all of that up. But I just wanted to show you that you can have it running here. You basically use VSim running and your analysis and your visualization, the same you would as you would normally do on your desktop. And in the background, we create some storage on Amazon so that you can have access to your data. So here's a run that I did previously with a simple example here, cylindrical capacitor. It has these data files, and they're on Amazon, and I can move them on and off Amazon. So I'm going to click on this other tab that I have over here that is the Amazon interface for my account. And this is the storage directory that we've created automatically. And they call them buckets on Amazon, and the S3 is their name of their storage service. But you can see here that there's this directory here, and these are the same files that are over here on this machine here. Now, you may say, okay, are they really the same files, or am I just showing you pictures? But you can see here that this is a run of one dump. So the data files here have _1 because there's one dump, and they match that over here. So if I just rerun with a different number of dumps, say I changed it to 2 dumps and then dump it times 0, and then rerun and delete, and now it's rerunning. Okay, now you can see I have _0, _1, _2, right? And now if I go back to Amazon and I click the refresh, you'll see I have 0, 1, and 2. So that is a live picture of the actual Amazon directory, the storage that directory is on the instance. Now I can kill the instance and the instance go away, but that directory remains there. And also, I just want to show you real quick, here's a terminal, and you could download them from the Amazon interface through the web browser if you want, but there's also Python tools, and we're going to try to experiment with some nice downloadable tools that allow you to get them locally. And so here's a tool where I just listed the bucket, the directory, and you can see those are the same files here locally. That was locally here on my computer. Okay, so let me go back to the talk. So let me just talk about in general how you might think about using the resources on Amazon. I just showed you how you can connect to one instance, but what kinds of instances might you start, and what might you need for different steps of the part of the workflow? And I kind of made this diagram to illustrate that you can actually pick different resources on Amazon to do different steps. They don't have to actually all be the same machine. Like, for example, if you're doing setup, which is the first line, it requires a lot of your attention and time, but it doesn't require a lot of computation. So you might pick a low performance instance on Amazon to work on during your setup of your problem. But again, it's the same storage. You have one storage per account. No matter how many instances you start, all of the instances will have access to that storage. So you could set up on one instance and then kill that instance and then go over and start a new high performance instance if you want to do your run. And or maybe you want to just run it a little bit and see if it works. So maybe you want a medium or low power instance, but then when you're ready to do your serious computation and how you need a lot of computational power, then you pick a high performance instance. Analysis or visualization, they're kind of in the middle. Sometimes you want power, sometimes you don't. Certainly, if you are doing some kind of the parallel visualization that Tom Jenkins just talked about in his last talk, you might want high performance for your visualization. Maybe not. Okay, so I want to kind of just go through a few different scenarios of what you might think about doing these work steps. So here's a scenario. So what I have over here on this slide is on the left is your client machine where your browser connection to no machine on the cloud would be. The top and the bottom are over on the right are both on Amazon. But one is to represent where the storage and the data is, and one and the bottom is to represent where the computing is. They call their computing Elastic Compute Cloud, EC2, and they call their storage S3. But those are just Amazon terms. But so here you might start on an instance. For example, if you're just doing setup, it might be a cheap instance, and you would run VSim on that and do your setup of your problem, and then you would end up with some setup data on the instance represented by the orange box on the bottom labeled setup. And you might then, right now we're automatically moving that setup to the storage service for you, but we're not really sure if that's the best way to do it. When you have different instances at the same time, you're accessing the same storage. Do you want them all synced? It's, we're experimenting, and this is under development, so we're figuring out the best ways of doing that. But we might want to give you the control to automatically sync it and move it back. But anyways, that would be represented by that arrow moving it back to the storage. So that might be like a setup scenario workflow. Here's where, okay, you might now want to pick a high performance computing node to do your, like an EC2 instance that is a high performance, and you take your previously set up data and you move it over to the instance. So that's the arrow going downward, and then run it through VSim simulation, and you get your output files that are visualizable, and you move those back to your storage. So that's another scenario. Sorry, I just hit my screensaver accidentally. Okay, hang on a second, I have to type my password correctly. Okay, and here's another scenario where you would be just visualizing. So you would be taking output from the storage, moving it onto an instance, and here it may be a medium fast instance or a fast instance, and you visualize it. And then here is kind of a slide to represent how flexible this whole system is. You could actually do some of the work locally. If you had a VSim copy on your local computer, you could set up locally, imagine setting locally, and then have the setup move over to the storage service and then execute on a high performance compute node in the cloud, the output go back to the storage service, and then move the output back to your local computer and then visualize it in VSim. That's sort of the full round trip cycle if you wanted to do that or not. But you get flexibility, you got lots of choices, and so forth. So now I just want to tell you a little bit about setting up the account, because I don't want to gloss over that. So let me show you what you actually need to set up an account on Amazon and connect it to the CloudSim service. So we have part of the CloudSim service is a place to enter your Amazon account, and I'm going to show you sort of the steps that we walk you through to create an account. If you don't have any Amazon account at all, this is where you would start. You would create a root account with these steps, and then you would give us the account number, and you have to pick a region. A region basically corresponds to a data center, a physical location that Amazon owns. And then within that root account, we don't want access to your root account. We want you to create another account, a sub account within your Amazon account that you do give us access to. And this sort of tells you how to create the permissions for that account. And it's not, it's not simple, but we walk you through, and the crux of the permissions is this one document here, which we generate for you. So we give you this document to cut and paste into your newly created sub account. And that's how you give CloudSim the access permissions that it needs to start up instances for you. Now, if you don't want to, if you feel uncomfortable giving us access, we can certainly give you the instructions on it, how to start up your own instances on your own account without giving us any access. But then you're basically having to then install VSim on your own, like you would on a normal workstation on your desktop. And that's possible and doable for you if you'd like to do that. So lots of choices. Okay, and then finally, creating the user account in Amazon looks like these steps here. It's not too bad. And you get an account, and then there's these access keys that you enter for us that gives CloudSim the access, and that's it. And then now CloudSim can start up instances, and I can show you how one would start up an instance. It takes about 90 seconds for the instance to actually spin up. And what it's doing here is we're sharing an image with your Amazon account with VSim installed already. And that VSim is going to be contacting a public license server so that we can track how much you use VSim. And you'll have to contact us to describe the pricing, but we're aiming for making it, if you're using VSim, like a few simulations a month, to be much, much cheaper than you would to buy that. So, I mean, I can wait for this to start up. It's almost about ready there. Let's see, while it's waiting to start up, I think I'll just go back and finish the last two slides of my talk, which are, I wanted to point out that Amazon has the capability to spin up a cluster. And they do, you can choose the type of nodes that you want for the head node and for the compute nodes and the number of compute nodes. And you can choose all the different, how fast you want those compute nodes to be. You can choose the scheduler that goes on the head nodes. And once you do, and those include schedulers like Slurm that John will probably show you a little bit more detail about. But basically, once you do that and you're running VSim Composer on the head node, you can submit to the cluster that you just spun up. And I've demoed this. I've made sure this works. It's not actually in the CloudSim product yet, but we're going to work on that. And one thing to note here is that the spinning up a cluster does a lot of overhead work for you in terms of networking and connecting all the nodes in the cluster so that they can do parallel runs. So they have to have security, and they have to have connections that allow NPI to work among the compute nodes in the cluster, and that's all done automatically and programmatically through the interfaces that Amazon has. So that's really nice, and we hope to have that working soon as well. So this is my summary slide. Basically, I just wanted to leave you with this is all exciting because it's a lot of choices. It's on demand. You only use what you want and what you need it when you need it. There's no hardware cost to purchase hardware. I mean, you rent it, of course, per the hour, and there's no IT costs at all involved. It's a really attractive options for some projects with limited resources. It's a good fit for when you have simulation burst needs in your design process, as I discussed. It could be an easier sale to management. Instead of saying, hey, I need this 1,000 core cluster to do my simulations because I don't want to wait a month for my simulation. I want to be able to run it in a few days. And so instead of saying I need to buy this cluster, you can say I need to buy this service at this cost per hour. And that's probably an easier sale to management. And so, yeah, does this sound right for you? We'd love to hear, what your needs are, or what you've heard today that might fit your needs, or if there's something that I haven't mentioned that would you've thought about that might fit your needs better than what I've talked about so far. So, all right, so let's see where John's at. I believe he's probably.
Very nice.
Yeah, I'm ready to go. And I'm thinking, you know, our talks overlap so much that we might want to wait and put questions there at the end.
Okay, that sounds good, John.
Okay. All right. So let's start over. And, you know, the nice thing about this is, let's see, excuse me, everybody loves it when the CEO makes a mistake. So at the very least, I hope I provided you some entertainment. So in any case, as I was saying, we're back to the private cloud. And remember, the private cloud has the convenience of what David was talking about, but it is where you already have your hardware, you want to use it, you want to work on it, but you want to share it among multiple people, and you want to do it easily, and they don't you want them not to have to download any software in order to do that. So when things went wrong was where I was explaining to you the requirements, and as I mentioned, you have to have a certain number of things, and as we just saw, it's also very useful to have a good group of IT people who can step right in. And of course, what the usual statement is they went back to the server and they restarted no machine to get us where we are. Okay, so what you see here is I'm in a browser. I've connected to our own machine, txcorp.com. We call it vCloud for the cloud for VSim. And I'm basically doing just what you would do as if you were on your local worktop or your workstation, except that I'm doing it through a browser and I'm actually working somewhere else. So as I said, you connect to it, no software, no license installation, just point your browser at the given URL. So how do we work on this? Well, it's not going to take too long because if you've used VSim, you know how we work on these things. We work on them just the way we do before. We open something up, and here we are, and we're in a browser. And this particular example is the example of doing me scattering, where we launch an electromagnetic wave at a sphere of metal, in this particular case, and we try to find how the electromagnetic radiation comes off in different directions. So it's a radiation scattering problem. Let's see here. I just want to make sure. Am I sharing the correct screen?
We can see VSim in the no machine.
Good. Well, then I got something right. All right, thank you. So now you do new from example, you could do that or whatever. Now, one of the things you need to have is you do need to have an area on that machine. Now you can do that in a number of ways. Your IT department can create for you, your user, and a space for you on that machine such that when you log in, you go to your home space. In this particular case, what you'll see is I am in my space. So I'm Cary - Colorado, this is called, my documents area. Otherwise, it's just exactly the same as if you were computing locally. Okay, so you need to have a workspace, a home machine on the directory, and we'll talk more about that in a second. Set up your problem, no different. You know, open your constants, set their values. Well, of course, you can't change the muon mass. You can change your constants like C sphere or R sphere. You can then view what you have in this simulation. I can come into here and say, oh, I really don't want that to see that RCS box. Let me unclick it. Oops, did the wrong thing. And I want to just see, let's look in here. I can see the CSG, and I want to get rid of the far field box. And the positional field is right here. That's what I got a history of. This is just one of our standard examples. And so here's a sphere that we're going to shine electromagnetic radiation onto. So all the setup is just like you are used to if you're a VSim user. Now, sometimes the browser refresh might not be as responsive as before, but as you can see right here, when you're on-prem, which is the use case for this, it actually works pretty well. How do you run the job? Now, here's where I'm going to tell you a tiny bit more about running through the system. In this particular case, we have set up VSim so that when you go to the run panel, here's the run. And here it shows the old log from the previous run that I had, as you know, if you go back to your directory. But I'll go to my run mode here. And this is a capability that we've implemented that allows you to pick a scheduler. You can run scheduler, serial, or parallel, but we can configure this so that only scheduler is available. So your sysadmin can say, nobody can run on this machine unless they run through the scheduler. Now, the reason that's good is because that then your sysadmin can limit so that if you ask for 10 cores and somebody else asks for 10 cores, they can limit it so that the total number of cores that anybody can ask for, let's say, is 30, which might be the number of cores on your machine, or 30 because that's the maximum number of cores in your license. And then the scheduler will not allow the second, an additional person to start up until the first one has finished. All right. So here I've said, I want to run here. I want to have 9 processes per node, limit of 1 hour in wall time. And I'll go ahead and run this and show you a little bit about what's happening when you run things through a scheduler. So I hit the run button and it's running. And what you see here is it shows you, I'm going to show you up here at the top, it shows you your batch mode submission script, which Composer has written, put on the machine, and then submitted into the queue. Now it submits it into the queue, and you can see it submits the batch job, prints out some variables for you, and then it starts computing away. It's so anxious to compute that it's not letting me do anything else. Now, while it's computing, I can be looking over in the file browser, and the file browser over here, I should be able to see various of my fields showing up. So I don't actually like this smart grouping because now I can see, well, I've got dump 0, dump 1, dump 2, dump 3, and they're being generated and put into your simulation run area on that machine. Let's go back to the engine log, and you can see it's in the middle of dumping. It's already gotten up to step 1000. And just like before, you have the various controls for your dumping that you would have as if you had it on your desktop. In particular, I won't do it now, but I could dump and stop. And that's the graceful stop where it tells Vorpal to the VSim to finish. Okay, now what does this say? Now, all the time while it is computing, it is looking at the queue to see if you're still working. So that's what's in this tab right here. It's the queue status tab. And so it keeps asking, hey, who's in the queue? Who's in the queue? And you can see every time it asks that only Cary-Colorado is in the queue. He's running something like called dielectric CO something, and he's running away. He's running and running his code. Okay. Over here, we see that more files have shown up. And over here in the engine log, we can see that we're now at step 2843. We'll go ahead and let this conclude because it only has to get up to step 4000, and that will allow me to show you how the analyzers work. But in any case, these are the new things you'll see. You'll see the log, the results from the engine. You'll see the status in the queue, where you are. That R means it's running. And you'll see the file browser, and you'll see your files showing up. So while that's running, I'll come back over here. It's now at 3200, and it has to only go to 4000. So it'll be just a few more seconds here. You can select, I should show you over here, all the different parameters that you might want to use. You might have different partitions in your scheduler system, like one for vCloud. We have another system where we have one set of machines that only have 12 cores per machine, and we have another set of machines that have 32, and those are different partitions. You can choose those and choose what you're going to run on, and you can choose all the different parameters that you'd ordinarily choose for parallel computing. That is to say, the processes per node, or the number of nodes, your wall clock limit, and so forth. Okay, we're getting pretty close down here. We're only 130 steps away from concluding. So give it another second here. There, 4,000. It's done. And when it gets done here, you will see that it's done over here. And as we go over to the scheduler operation, this says it's done. We look at the queue status, and we should see that it is no longer found in the queue, assuming completed. So it changed from running to complete. So it follows the queue for you. Okay, great. So auto detects your queuing system, does the same kind of job control, generates a submission script, and submits it. And by the way, that submission script can come in very handy, because you might want to go back and say, hey, I have that submission script. I might like to modify it a little bit, rename it, modify it, and do different things with it, like use it for a scaling study, like change some parameters inside of it. All those things you're used to doing, for those of you especially who are using text setup. All right, so what happens next? You ran it, we saw that, we saw the queue status, we saw the file browser. So now you can analyze your data, and what a surprise, it's just like before. So here's an analyzer panel. Here are the parameters in the analyzer parameter panel. And you can now look at this in your parameter. You can tell it, if you have a variable defined in your input file, you can tell it to use that variable value in any one of the fields you need for your analyzer. So that's another new thing coming along. So now you hit the analyze button, and this should be reading fields and analyzing away, and analysis completed successfully. Right now, this is being done in serial, and that would be on the workstation or on the head node, depending on what you have. All right, so now we've seen analysis. Click and go, and we have some new capabilities coming in there. As I said, you can set analysis parameters from the parameters in your input file. And finally, visualizing. Well, this is a workstation, and so it only has one node. But you can imagine that if you wanted to visualize on the one node of a cluster, you would make your head node have a whole lot of memory, and then you would have your compute nodes probably have less memory. They don't need it because they're computing in parallel. But then you can visualize right now on the head node. So let's see what we have here. It's loading the data. It's all being done over there. And this is a history. So remember, I had that little ball out there in my geometry window, and this shows the positional field 0_0 history as a function of time. And now you can do pretty much all the usual things. You'd say, hey, what's the Fourier transform of this? Well, look, it's a nice, very sharp frequency at this point and falls off. Okay. What else can you look at? And let's see, here's a data overview. Well, here I'm showing how we meshed up that ball, that sphere. And look at that, it's just as responsive as it was before, as Mark was showing you on his desktop machine. You can now do all that through the browser. Okay, so let's move on here. Okay, but you said, well, I don't want to do everything through the cloud because, heck, I've generated everything on my local machine. How do I get it over there to the cloud? In the case that David showed you in Amazon, you have a shared file system on your desktop and Amazon. Those are called the S3 buckets. You could do something similar to that here, but in the event that you don't have that, you can just do regular old SSH commands on the command line. So I could, for example, have my over here, I'll get that to you in just a second. I could have a terminal window. And in that terminal window, I might have an input file, which I will make. And now I do, for this transfer, have to know, and let's see, in order to do this, I think I have to step out of presenter mode and go into regular mode in order so that I can copy and paste from my presentation. So now I can say, hey, I want to send that over there. So, oops, that doesn't like that. So I'll have to do this in 2 steps because I have a brain dead terminal system. So I'll do this, I'll copy and paste that over here. This thing is not being cooperative. I'm not having really good luck, am I? Let's see if I can get that. And copy the rest of it. And I'm just going to copy it to that directory. Copy. Paste. And now I have to remember my password. Oh, I guess I don't. But if you do remember your password, then that would go right over there. Oh, I remember now, this is a different username and I've forgotten the password for this username. So in any case, if you're familiar with SSH, you can just do SSH commands, both to send files over there or to get them back. You can get a history back and look at it locally on your workstation. And if you don't have VSim Composer installed on your workstation, as Tom Jenkins just showed in an earlier talk, you can open up this file using Visit, which you can download from the Livermore Labs. So that's how you communicate between your desktop machine, and you don't have to have Composer on your desktop machine to do that. All you need is a browser. All right. So now you say, well, this looks like a lot of work for my sysadmin, and every time I go talk to them, you know, it's so difficult to get them to help me because they're always so busy and our company hasn't hired enough sysadmins or whatever it is, or I have to do it myself. And gosh, every time I start doing some system administration, I end up on Google for 3 hours trying to figure out what the next correct command is. All those things could be reasons why you don't want to do that. So for that, what we're coming soon here is a way where you could get an account from us on our machines and then just go to your browser. Let's see if I can do that. And go to here and request an account from us on our machine. Give us your name, your institution, your email, select a password. And ultimately, we have to get a credit card from you, of course. We haven't set this up yet. We don't even know what we're going to charge yet. But if you did that, then this would be a mixture of somewhere between Amazon and the private cloud. So the use case for the private cloud, remember, is you have your own equipment and you want to keep your data on your own premises, but you want to share a machine. For the public cloud, you don't want to buy anything, and you're happy to work with Amazon, and you really love the fact that Amazon has a huge number of computers of all different capabilities. Or thirdly, you're willing to come to TechX, you really only need a workstation for a little while, and you don't want to go buy one, you just want to do some computing. So that's what I say coming soon. Just pull that credit card out of your wallet, and we're going to be able to work with you. You will again have no capital expense, no IT department costs. And the nice thing about this for many of us is it avoids, management's not going to like this, but it can avoid management, because I don't know about you, but when I work at the University of Colorado, how it works is that I'm being given a credit card and I'm allowed to spend on that credit card up to a certain amount without prior approval. Of course, like any institution, somebody will always examine what you spend stuff on, and you may have to justify it later. But you say, hey, I need this simulation done. I got to understand this by the end of this week so I can submit some proposal somewhere. Well, then you're going to be able to come to us and do that very quickly without any cloud Amazon account ever, just with our account, and get that done. Now, I want to stop here for a moment and get your feedback. But in particular, some of your feedback, I'd hope that you can email us, because we're looking at 3 different ways of making it much more convenient for you to do computing. Private cloud, really public cloud like Amazon, or this TechX cloud, and they all have their different advantages. And as we are developing, what we are, of course, interested in is, what do you, the customer, want? What would you make the most use of? And so we're very interested in that. So for now, though, what I'm going to do is I'll continue sharing here for the moment, but I'm going to stop talking, and we'll take questions now. And when you ask your questions, please let us know whether the question is for me or for Dave or either one. So thanks very much.
Okay, there is a box at the bottom of your screen where you can submit. It says Q&A, and you can type questions in there, and then we can answer them. So it looks like you already have a question that I don't know that we quite have the answer to yet. How will you charge for the license on AWS? Core hour based?
Yes, we will be core hour based on AWS.
Okay. And can a private cloud be run in intranet?
A private cloud can be run on an intranet as long as you have, all the things you need on an intranet, namely some way for people to locate the machine, some sort of intranet name server, etc. Yes, the thing I was showing you was in fact on our intranet.
Do we have to give up any functionality to work on a private cloud?
I don't think so. I mean, you saw me walk through just about everything. You can do all the setup and everything. So the only thing is, your data ends up on that computer over there. And if you want to look at it locally, then you'll have to, or do some complicated data analysis on it, you'll have to bring it back through some mechanism. I've shown you how to do it through SCP. And alternatively, your institute or entity could, in fact, have some way of doing disk sharing in your intranet. And that's another way to take care of it.
A related question was asking about limitations with working on a private cloud.
And I think, thank you for that question. These are all great questions. I would say the only limitations are going to be related to your bandwidth of your local networking for the private cloud. As you can see, we have pretty good bandwidth. You never saw any slowing down. But if you're, say, working at some huge company that has the code somewhere, I don't know, in Nova Scotia, and you got to get off through the internet all the way from there to, Billings, Montana, that might be difficult. The bandwidth might not be so great. But I think that's the only limitation that I see is bandwidth.
Okay. Can you use Visit effectively on the cloud?
Oh, yes. In fact, not only does Visit work really well on the cloud, Visit works really well because Visit actually is already client server. You would have to start up a Visit server in the back end on the machine that is where we were running Composer. So that would take a little bit of work. That would be something for your sysadmin to do. They give good instructions for how to do that, though.
So no name machine, does that have to run over the internet?
It actually is all running back on your, in our case, vCloud. It's running on your cluster's head node. It's running on a remote workstation. It's running. Yeah, go ahead, Dave.
I was going to say, you might mention that no machine has a desktop client, and so you aren't limited to the browser. you can use their desktop client, which might be optimized in a slightly different way.
Yeah, Dave's right. They have a client. So if you don't have a browser that's totally compatible with all of the things that No Machine expects, then you might use your browser.
How is a private cloud different from a remote connection, such as RDP?
Well, if you have RDP, remote desktop protocol, if you set that up, you need to set up that server. That's a special server that you need to set up on your workstation. Now, many of them have it, right? You can use Microsoft Remote Desktop, and that's equivalent, although we've had problems with Remote Desktop. Mac has something, and then the RDP, whatever the name of that package is, Daniel Main knows what the name of it is. I can't remember it. He uses it all the time working at Princeton Lab. All of those things can work. It's just that we are trying to make it as convenient for you as possible. That's what I mean. You can use VNC. Yes, you can certainly use VNC, as I see Udo is asking. Any of those things work. Do VNC, but you'll have to install the VNC server on your head node. Once you've installed it on your head node, you can then just launch VSim Composer the way you ordinarily would, and it'll automatically find your queues and submit them for you, and so on and so forth.
And John, maybe I could add, VNC is good, and we had to make some choices about which kind of remote protocol we wanted to connect with these machines. And we did choose No Machine because of a specific reason. The connections are very optimized. They're fast, and they're faster than the typical free VNC client server connections. And so that's why we chose No Machine. For the problems that we had today with it are just kind of user error, but I think that we can, we're just learning about that. We have a relationship with No Machine, and we can ask questions of their technical support and get the configurations of these machines a little bit tighter and easier. But we did pick No Machine for some very good reasons, and I wanted to point that out.
Yes, thank you, Dave. No Machine does have a very standard X protocol is known as being very chatty. That is, it sends lots of packets back and forth, and it makes you have to have a higher bandwidth. No Machine has really optimized that well. Okay, Daniel Holland asks, the first core is 833 and over 512 was 40. Are all cores up to 512, 833? No, there's a sliding scale. And there's a table lookup that we can give you if you ask for pricing. So, the intermediate cores are, only a few hundreds a piece or something. And at the low end, they're 800, and then at the high end, they're really cheap. So this is a solution, by the way, that gets around, some people want a shared license so that they can have a whole bunch of people on different workstations use that one license. When one shuts down, the other one can start up. This is an even cheaper solution than that, because if you've got one bit machine with a whole lot of cores, then you get a much cheaper price than the shared license. And Ming asks, if I use different software in AWS, am I charged by TechX when running VSim only? Yes, that is correct. The clock starts when you start up VSim Composer, and you get charged for the visual. We haven't worked out the charging algorithm yet, but you'll get charged for that until that shuts down. And then but if you're in Composer and you launch a job, you'll get some additional charges because you'll be using more cores. And then when the Vorpal engine shuts down, then that charging goes away, but then you go back to just having the VSim visual setup charging.
So on that, what are some of the security features being considered in connecting the AWS instances?
I can take that, John.
Please do.
Yeah, so as I showed before, we connect with a No Machine to an AWS instance. And I want to point out that not everybody in the world can connect to that instance. Our when the CloudSim web app starts up your instance for you, it also configures it in a way that the security only allows connections from the IP address that you created the instance from. So there is an extra security feature there. Plus, you're logging in once you connect to the instance with that URL. You're logging in with a login username and password that only works on that instance, and you will only know that password if you're in your account in CloudSim. So there are some security features built in there for securing that. I also want to mention that we are aware of Amazon's features for different levels of security. For example, Amazon has the .gov cloud, which I think, John mentioned that if you're working at Raytheon, you would not want to be using Amazon, but I know for a fact that Raytheon is using Amazon, and because they're using the .gov part of Amazon, which is secure to DoD standards. So there are possibilities of different security features within Amazon that you get automatically because you're just getting a regular Amazon account.
And when can we expect this to come? I don't think that's.
Well,
with the Amazon.
I always hesitate to predict, but I would say sometime early next year. But if any of you say, what I really want is Amazon, or what I really want is private cloud for our institute, and, we're ready to buy a license right now, that will strongly determine where we put our resources for development.
Okay. Any final questions from anyone else before we finish out this 3-day presentation series? Despite our little technical hiccups, you guys have done great. And it was helpful to have 2 presentations, certainly, to switch between. Anybody else? All right, I guess I will close out. Thank you everyone for joining us from all over the world. We appreciated having so many people, so many amazing questions were asked, so many good presentations were done by my staff and by our users. We really had several different users this year, which was a little bit different than what we did last year. All of our presentations have been recorded. They will be edited and put up on our YouTube page for you to watch again or to refer back to. They should have all of the talks by the end of next week. Some of them are already there. And of course, if you would like to evaluate our software and get the latest version, please go to txcorp.com and request evaluation up at the upper right of the website, and we will get you a 30-day evaluation of the latest version. Thanks so much, everybody. We will see you again next year.
And if I may say once again, how much I want to thank all of the presenters throughout this entire 3 days, and thank all of the attendees for their great questions. And now, if you can help us a tiny bit more by giving us some feedback on what we can do best to serve you, we would greatly appreciate that. So thanks again.
Thank you, everyone.